Okay, good afternoon, everyone. So my name is Sanjeeva. So with me, I have Arshad today. Okay. Okay. Okay, so till that I'll start session. So basically in this session, we will do initial introduction. So then we will discuss growing complexity of API management ecosystem. So basically every day we are adding new APIs, we are bringing new control planes, there are new identity providers coming, there are new AI capabilities coming in. So how this complicate the API ecosystem? So then we will discuss about different approaches we follow when we have this requirement. So basically how we can address that with the centralized and decentralized API management. But it's not here.
Yeah, now we'll go to
finish. Okay. Okay, thank you. Okay, so then we will discuss about the requirement of having a single control plane plus federated gateway architecture. So where we can have multiple gateways from different gateway providers. So then we will have a demonstration one. So where we explain how you can plug in a unified control plane, basically WSO2 API manager control plane, and how you can connect multiple different API gateways. So in this lab, I will show you how you can connect AWS gateway and Solace broker, as well as different WSO2 API gateways. So we'll cover that part with the demo one. So then we will discuss about Ingress and Egress API management. So we all know about Ingress API management. So Egress API management is quite popular these days due to growth of AI and LLM APIs mainly, as well as the other cloud services. So we'll discuss both of these. So then we will show how you can implement effective Egress API management for your AI APIs with WSO2 API Manager. So basically how you can apply different quality of services, token-based rate limit, all these things with WSO2 API gateways. So then we will discuss a bit about our roadmap related to these feature areas, as well as we conclude session with key takeaways and next steps. Okay, so like I mentioned earlier, these days API ecosystems are getting complicated. So when we start API management way back in 2010-12 timeframe, we just have one single API management platform, and there's one API management team, and they take care about everything. But now things get somewhat different. So there are different cloud vendors out there. So some of your microservices may reside in Amazon, and some of your services may reside in the Google Cloud. So when it comes to API management, you need to have API management also across these different cloud vendors. So sometimes we need Kubernetes native API management system. So likewise, there are different environment and cloud-related requirements are coming up. And also when it comes to protocol or use case, so now there's a trend to have API gateways for those specific use cases as well. So for my AI APIs, there's a separate gateway. So for my all outbound traffic, there's another API gateway. So likewise, there are different gateways also come into picture, and based on the protocol as well. So for WebSocket, you may have API gateway which is specified or specifically designed for that particular task. So when it comes to GraphQL, there can be another gateway. So likewise, there are different gateways coming up with different requirements. That is also another requirement, and the protocol as well. So when this API gateways and API management platform grow like over the time, these complexities these complexities basically drive your organization into some situations where you don't have complete control over your APIs. Because so now these APIs are fragmented across different areas, and sometimes you may lose the track of these APIs. Like you don't have one single control plane where you can see all your APIs in one place. You can't see how your API is being adhering to your organization policies. So that kind of problems are coming up, and when we speak to our customers, every day we notice this. So then some people think decentralized API management is a solution for that. So I'll start with the brief overview about decentralized API management. Then I'll discuss about some problems associated with that. Then we see whether decentralized API management can completely solve this problem. So if we consider decentralized API management, most of the time what we have is decentralized or independent control planes. So for example, if you have AWS gateway, you have AWS control plane. So Azure, you may have a separate control plane for that. So then when it comes to WSO2 API management, there's a WSO2 control plane, but there's no central control plane. So different control planes are there. And when it comes to policies, again, different gateway providers may have different policies. So especially if you take larger organization, within that organization, there are different business units. So finance department, HR, and engineering. So likewise, there can be different departments. So they may use different gateways, different control plane, as well as different policies. And also governance also vary across different teams. So one business unit may have API design best practices guideline that they follow. So that can vary from another department, like HR department. So within the same organization, there are different practices following. So then when it comes to traffic routing, there are different gateways. So these different gateways handle traffic for each of these business units. So then when it comes to infrastructure, again, they can use their own infrastructure. So there's no standardization or governance across how we use this infrastructure, even though they all belong to same organization. So then, so if you look at the advantages side, then it's flexible, right? So you don't have a central API management team where you need to go and ask for gateways, ask for policies and best practices, approval. So those things are not there. So that we can see as a plus point. So then when it comes to deployment, it's again quick. Because, so if you take this central IT team and the centralized API management, most of the time, you need central approval. There will be always one gateway, and that gateway shared among like different business unit. So now with this approach, you can deploy your gateways, your APIs, and you have complete control. So it somewhat make things fast. But if you look at the problems associated with that, so the number one is lack of standardization. So different business units follow their own approaches. When it comes to governance security, they follow different things. Can be a problem in the future. And also there can be security risks because there's no central governance. Different people follow different approaches, can be a problem. So when it comes to scalability, again, there can be issues. And when it comes to observability and monitoring, probably these different business units may have their own analytics and observability, but we don't have central observability or monitoring across the organization. So then when it comes to versioning and dependency, there can be again conflicting as well, because these are like disconnected processes, so that we don't have central control. And also when it comes to operational overhead, it's again can be significant compared to other models, because each of these deployment or each of these gateways managed by different business units. So they need to build their expertise related to infrastructure and all other aspects as well. So these are some of the problems associated with decentralized approach. But if we take like last 5 years, 6 years time frame, I would say we have seen like more of a decentralized API management approach across different countries and different industries. So then you might think, okay, decentralized API management is too complicated. Should I go back to centralized approach? So something we had like decade back. So in that case also, let's look at what is the centralized API management. So centralized API management main characteristic is you have single control plane. So all these things happen with the single control plane. And when it comes to policy security, all these things are like the unified across all the business unit. They can use them, but that is defined and governed by one single entity, which is usually API team. So then when it comes to traffic routing, most of the cases, it's just a one gateway, which is like the scale for the like the TPS requirement, obviously, but it's mostly one gateway. And when it comes to infrastructure, again, this central team that I discussed, they take care about like the hosting management aspect as well. So standardization, it's very easy because governance rules, standardization, all these things happen from the single team. So we get better control. And most of the time, there can be approval requirements are there because when you, as a business unit, when you request, it goes to central API team and that team will approve that. So that's how it works. So then again, problems associated with that. One major thing is slow onboarding. So since we have this central API management team, which can be bottleneck because they get too many requests from different business unit. So they will have to go through these requests one by one, and then it can take some time. So when we provision APIs, provision gateways, it can take some time. And also it's somewhat limit the flexibility because other teams need to wait for central team's decision. And also most of the time we will have generic solutions because central IT team evaluate different requirements coming from different business unit. And based on that, they select the gateways, they select the infrastructure. So they have control. Sometimes the solutions that they provide may not suit for all the business unit. So it can like cover most of the requirement. But let's say if new business unit come up and they want eventing APIs, so probably it may take some time to onboard these API types or API gateways into system. So innovation obviously can slow down, and when it comes to scalability, there can be again limitations. And also when it comes to operational cost, again, so this approach also, if we haven't followed the best practices, there can be operational overhead because the central team get more work, so they need to have more team members, so that can also be an issue. And also, it will somewhat limit the control over API deployment or the development teams are doing, because no matter what, each business unit, they have to go through this approval process. So they may do half of the work, but some of the work need to be done by central team. So then, like I mentioned earlier, when there's a new technology come up, adaptation may take some time because the central team need to evaluate that, and they need to do all the testing part. Then over the time they will onboard, but it may take some time. So these kind of problems are there. Okay, so now due to these problems with the both approaches, most of the organizations these days we are seeing following a middle path, where they try to utilize advantages of both of these centralized and decentralized API management. So in next few slides, we will discuss how we can utilize both these capabilities and how to implement API management solution with a single control plane with an federated API gateways. So first I will explain about requirement of having central control plane with the federated gateways. Why we need central control plane? So basically, with the previous approaches, with the decentralized, main advantage we are getting is the autonomy and like the flexibility that teams get. On the other hand, with the centralized approach, main advantage we are getting is more control, governance, and the security part. So with this approach, what we are trying to do is to bring both these capabilities and have one solution. So when we need to have, if we discuss why we need to have central control plane, most of the time they need to have, they need to manage different API gateways across different environment. So these gateways can AWS, Kubernetes, Solace, or anything like that. So this central control plane should be able to manage all different gateway types. And when it comes to like the management part, that includes policy enforcement, security monitoring, all these capabilities as well. So then one key question is we need to have is like how we can centrally manage different gateways. So as of today, most of the control planes we have out there do not support that. They can manage a specific gateway, but when it comes to like the different gateways, most of these vendors cannot support that. So one other thing is we need to think is how do we ensure security, governance, and the operational efficiency across multiple gateways. So some people can like the connect to gateways, but how we can look at security, governance, and all other things from one single control plane is the question we need to think through. So then if we further dive into control plane, so what is the API control plane? So it's a kind of a centralized system that can manage multiple APIs or API gateways and the gateway deployments and apply policies, governance, and other related stuff. So key capabilities include unified ingress and egress management across different gateways, as well as the policy management, governance part, and the observability and analytics, like I mentioned earlier. So then, those are basic capabilities, but if you look at some extended capabilities we expect from the control plane, that includes policy management and observability, access control, automation, and ability to support hybrid deployments where we have like part of your gateways in the cloud and other part on-premise. So there can be cases like that. So how WSO2 support this is you can see in this diagram. So from WSO2 4.5 onward, so this is the architecture we are pitching. So we introduced one API control plane. So this single API control plane can work with multiple gateways. So I think most of you are our customers, so you know about our gateways. So we had the standard gateway. We call it standard gateway or enterprise gateway, which is Synapse-based one. So from this release onward, we are going to call it universal gateway. And that will be basically good for like the different protocols and mediation, integration, all these capabilities are there. So then some of our customers are using WSO2 micro gateway, which is Barcelona-based API gateway. It's specifically designed for run in isolation mode or immutable fashion. And some customers use that as edge gateway. Some are use that as a sidecar gateway as well. So we call it WSO2 micro gateway. From this release onward, we call it immutable gateway. So I want to highlight these terms as well because from this release onward, we are going to use those names. So then some of you already used WSO2 APK gateway. So we called it API platform for Kubernetes, and that has a gateway. And that gateway is the ONOI-based one, which is adhering to Kubernetes Gateway API specification. So from this release onward, we are going to name that as a Kubernetes Gateway. So now what we have is we have a central control plane and 3 different gateway types from WSO2 side. And this one control plane can manage and govern all these API gateways. So it's not just limited to that. In addition to that, we can support federated gateways as well. So this release, we introduce AWS API gateway support as well as the Solace broker support as a federated gateways. And there are some features coming up. I mean, in the future, we bring more and more API gateway types. So then we'll discuss about gateway federation as well. We discuss about multiple gateways that we support, and there are some gateways out there from other vendors. So when we implement federated API gateways, there are certain challenges, like the centralized management, fragmented traffic control, varied configuration, and the UI related inconsistencies. So all these complexities are there. So let's see how we can handle that. And how this multi-gateway or the federated gateway solved it is, we provide you one single control plane for the centralized management. And also when it comes to security and policy, we provide the standard policy and security framework where you can define your policies. We take care about applying these policies to different gateways. So these policies and policy execution can vary from one gateway to another. So we take the responsibility of converting that to right policy and apply to different gateways. So that's how we solve that part. And also when it comes to UIs also, we have flexible UIs, and we collect fields or inputs from the users. And by the time we do the actual gateway deployment, we do the conversion and we pass that in a way that other gateways can consume. Okay, so then this is another detailed version of what we support right now. So our gateways are there. So then in addition to that, AWS Gateway, Solace Gateway are there. And also this particular architecture support onboarding another gateways as well. So this approach followed by, with this approach, we do have agent concept where you can write agent based on any gateway. So all these are like agent-based connections. So we have control plane, and then we have one agent for Kubernetes Gateway. There's another agent for immutable gateway. And likewise for the federated gateways as well, we do have agent. And you can write your own agents and bring any API gateways. So as of today, we support 2, but in the future we will have more because with this flexible architecture. So as WSO2, we don't need to implement all of these things. So we believe our customers and users will implement some of these agents as well, because with the framework that we provide, they can write their own agent and plug any gateway that they want. So in the future, if you have a situation where we need to bring your own gateway, we can also support that with this approach. So then I'll jump into demo. So here's my scenario. So we got organization called Forbes Logic, and this like the organization, and they want to implement API management. And one of the challenge they are facing, they need to have different gateways across different environments, and managing policies, traffic, that is the problem they are trying to solve. So then we do have this top level business unit. So then under that, there are different teams. So team 1 is eventing API team. So main responsibility of this team is to produce and enable API consumption for eventing APIs. So then there's another well-established team, which is financial services team. So they have set of APIs for that business unit as well. So then there are other IT teams. So then we will go into requirement of each of these teams. So like I said earlier, eventing API team need to use like the eventing or the async API kind of APIs. So their requirement is to use some sort of broker. So possibly they will go for Solace broker for that one. So they pick Solace gateway or broker for that use case. So then we got financial services team. So their requirement is all their services are now deployed in the Kubernetes architecture. So we can think of like a situation where they had like a monolith application. So they break that into smaller microservices and move this entire deployment into Kubernetes. So now all their services are in the Kubernetes cluster. So now when it comes to API management, you can't have a gateway that runs on VM, right? Because it's a Kubernetes native system. So possibly you will need your gateways also in Kubernetes. So their requirement is to have Kubernetes native gateway. So for that, we offer WSO2 Kubernetes Gateway. So then there are cloud services team. So all their services are running on AWS cloud. So one requirement for them is like all their gateways need to deploy closer to their backend. So possibly in that case, they won't go ahead and use WSO2 Gateway because all their services are running on AWS. So why not use WSO2 Gateway, AWS Gateway? So due to that fact, that team decided to go ahead with AWS Gateway. So then there can be other teams. mainly catering 2 different regions globally. And their requirement can be like the running mediation policies, support various protocols. So if you have that kind of requirements, our obvious solution is our universal gateway. And it's not just the one gateway, but we propose them 2 different deployments of that gateway, one in Europe, one in APAC, so that they can address all their use cases and different region specific policies and all, they can handle with this approach. So this is the use case we are trying to build. And for this implementation, we are going to use different gateways. So if time permit, I will explain all these gateways. But if time limited, I will go ahead with few main gateways and show how it works. So any questions up to this point? Is that make sense? I mean, is it a real requirement for some of you? Okay. A good question.
That's only one question. Why AWS is treated as a special case and not GCP and Microsoft Azure? We have the kind of hybrid.
Yes. So we pick AWS because there are some customers who want to use AWS Gateway immediately. So we prioritize that. But it's not just limited to AWS Gateway. We'll be onboarding other gateways. So immediately after this release, we will release Kong Gateway plugin. And then we keep releasing other API gateways as well. So obviously, yes, FG, all other capabilities are coming up.
Thanks.
Do you have an ETA for packaging?
Not right now, but I'll check and let you know. So as soon as this work completed, plan work completed, I'll check and let you know.
Hello, quick question. You've mentioned the change in the name from different gateways. So there's an immutable gateway now.
Yeah.
So there's been changes in this immutable gateway from a technology perspective. First, it was WSO2 Micro Gateway, then Courier Connect, and I believe you're now going back to WSO2 Micro Gateway, right? So what's the roadmap primarily when it comes to immutable gateway? Are you looking at promoting Micro Gateway? Or yes. Are you looking at promoting Courier Connect?
Yes. So Micro Gateway, we will be promoting for all the immutable cases. So Courier Connect, probably you know, it's based on the ONOI, right? So now, if you consider WSO2 Kubernetes Gateway, it's more aligned with the Courier Connect because it's again based on the ONOI runtime. And we mainly pitch all of our customers who are using Courier Connect to consume our Kubernetes Gateway because that's the future. But we will be supporting Micro Gateway and we will be doing releases and we will be adding new features to Micro Gateway as well because some of our important customers still use the Micro Gateway. And as a gateway vendor, we see demand for that as well because we are getting that requirement every day.
But do you plan to promote or maybe have WSO2 Kubernetes Gateway also support immutable features or?
No. I mean, we don't have any plan to support immutable nature for Kubernetes Gateway. But if someone need to do that, that is also possible. There are ways that you can do that. But primarily, if someone asks for immutable gateway, our recommendation is to use immutable gateway.
Okay, thank you.
Thank you. Any questions?
We are exposing more than 100 APIs over the micro integrator in company internal. Would it be feasible as well to put it on that scenario?
Yes. So if you are using micro integrator today, we do have a concept called service catalog, where you tell micro integrator where your API management services are reside, so that every time when you create microservices, integration service in your integrator, it will notify track to API manager side. So in the API manager side, we do have something called service catalog. There you will see all the services that you deploy into integrator. With just one click, you can convert that into API. And also if you need, you can automate that as well. So all your 100 APIs will be converted to API at once and available in the created state. Of course, you can go ahead and publish and deploy into different gateways as per your requirement.
I have a question on how do you integrate with AWS Gateway? If we have our own customized API control plane and gateway, right? Do you integrate directly with the control plane APIs of that custom solution? Like AWS Gateway has a control plane API. That's how you integrate.
Yeah, that's how we do that.
That's the question.
So basically our agent, so this agent, we will pass all the information that we stored in our, so that include policies and metadata and all this runtime data as well. So that agent will convert that and call to whatever the gateway's API. So in your case, it can be customized control plane that you all are using.
And I assume you have a framework for building these custom agents.
Yes, there's an interface and you can do the implementation. It's a complete framework that you can plug in gateway, multiple gateway.
Great, thanks.
Welcome. Okay, so then I'll go ahead and do the demonstration. First, let me log into WSO2 API Manager's admin portal. So admin portal, if you all are not familiar with that, that is the place where you do all the admin related operations, basically create policies, manage different gateways, manage key management. So all these admin related tasks you do here in admin service. So I enter my username and password. So once you log in into admin portal, there are different capabilities like I mentioned before. So like creating policies, different gateways, API categories are there. So this part of the demonstration, I'm going to primarily focus on the gateways. So let me go to gateway section. So in the gateway section, I have configured 6 different gateways, gateway environments to cover that use case. So if you remember the use case that we were discussing, there was a requirement for us to have like the AWS gateway. So that is what you see down here. So then there's a requirement for us to have Kubernetes native gateway. So that is what you see second from down. And then there are 2 gateways that we want to deploy regionally, APAC and the EU gateway. So those are different gateways. So adding gateway environment is very simple. Basically, you can go to add gateway environment section. There you can provide the name, display name, description, and also you have freedom to select different gateway types. For this particular use case, even though we have like 4 or 5 different gateway environments, there are 3 fundamental gateway types: Universal Gateway, Kubernetes Gateway, and the AWS Gateway. So you see these things because I have added connectors for those different gateway types. So if you write your own gateway connector and then you add that to API Manager platform, you will see that gateway type also here. It's very easy. So then you pick whatever the gateway type you need, and then you categorize that as a production sandbox or hybrid. It's a kind of a label that we use. And also you can set the visibility, whether this particular gateway is a public one or else it can limit for specific roles, it can hide for specific roles. This feature we require especially because in the developer portal, when you see APIs, so in the past, we used to show all different gateway URLs for different regions. For this particular feature, you can set different roles. So for example, if it is a EU gateway, you can set roles, something like EU role or something like that. So only when those users log in, they will see this specific gateway URL. So there's a one API, but when you go to that API, there are multiple gateway URLs. Based on your logged in role, you will be direct to right gateway, which is closer to you. So then if you're using vhost feature, then you can add vhost entries as well. I'm not going to go into that path. So likewise, we can add different gateways. So first part of the demonstration, I'm going to create API and deploy that into AWS Gateway and show how we can invoke that API. So to do that, I'm going to go to WSO2 API Publisher. So this is the place where we produce APIs. So mainly this portal is for creating APIs, listing APIs, apply policies, then again product management related stuff where you add documentation, policies, role-based access control, subscription related configuration. So this portal mainly used by API producers, so API product managers, whereas previous one used by admins to govern entire API ecosystem. So there are few APIs I created already. Let me add one more API. So for this one, I'm going to go ahead with the import open API. I don't want to go into AI path because Pugudu and team already demonstrated those capabilities. So I'll go ahead with this very simple basic use case where I import open API definition. So I have some already created APIs. So for this particular use case, I'm going to pick financial API YAML. So then I can go ahead. So when I try to create this API, again, you can see there are multiple options. There are like 3 different gateway types available in this environment. Universal Gateway, Kubernetes Gateway, and AWS Gateway. For this particular use case, I pick AWS Gateway. Then I'll go ahead. So now my API created in very basic level. So then what I need to do is add AWS specific keys to this API. Because when you create this API in the AWS Gateway side, these attributes need to pass. So for that one, I'm going to use policy concept. So policy might not be the like the ideal way of doing this thing because it is not something related to runtime mediation part, but you can think that as some attribute linked to this API, right? So don't think about policy as a mediation policy, just think as some attribute that you link to this API. So how we do that? I'll go to policy section and then API level policies. So then I'll go to common policies, then I have AWS auth. So then I need to provide Lambda ARN and also the keys related to AWS. So I'm going to add these things and then I'll save this API. Okay, so now this API saved. So since I picked AWS API gateway type, there's one single gateway configured with that. So you will see that API gateway here. I can deploy to that gateway. So I'm going ahead and deploy to that gateway. So now what it does is it will store all the metadata in WSO2 API manager side in our database and schemas and take a copy of that and call to AWS gateway agent. So that gateway agent will take care about communication with AWS gateway. So now it says it's successfully published. And then let me go to lifecycle status as well. Then I'll publish this API. Okay, so then I'll go to AWS gateway. So as of now, you can see there are 2 different APIs I already created. So this newly created API should appear here, and we should be able to send requests for that as well. So I think I need to sign it again. I'll use admin access because it's easy. So once I logged into AWS console, I'm going ahead and okay, I'm going to select API gateway. So now you can see 3 different APIs. So financial data API I created right now is also now you can see here. So now let's try to invoke this API. So in that case, we don't need to go through our gateway. We will straight away call to AWS gateway. So all the URLs and all the configuration available in the portal. So let's go to developer portal and try to invoke this API. So this is our developer portal. Let me log into that as well. Okay, I think I logged as admin, which is incorrect. Let me sign in as a standard API consumer. So for that one, I think I heard login as a David. User 1234. Okay, so this is our developer portal. So those who are not familiar with the developer portal, this is the place where you consume API. So basically, this is for API discovery and API consumption. If you have any specific requirement, this is the place where you come and you search for whatever the APIs you need. Then you try out these APIs, you read the documentation. Then eventually, when you are familiar with this API, you sign a contract, and then you start consuming this API. And all these AI capabilities explained, you can see right down there. So now I can see my financial data API. Let me go ahead, click on that. And here, first I need to obtain access token. So first let me do that. I'll go to this default application, go to production keys, and create access token. I'll create simple token without any scopes. Because for this one, I just need a JWT token that I can pass to AWS side. As long as it's signed by the JWK supported provider, they can consume that token. It's a very like the basic security level. We don't have any scope-based permissions or like the multi-step authentication where you need to get access token. But it's a basic one, but I think I just need to cover the scenario. Okay, so now I got my key. So I'll go to API console. So, sorry, I think that didn't copy. So these AWS gateway hosted APIs, we don't need the specific subscriptions because that is mainly managed in the AWS side. Okay, I'll copy token. Then I'll use it here. I'll go to console and paste my token here. So then, as you can see here, this AWS gateway URL automatically pick and appear here. So every time when you do a call, it will straight away go to AWS gateway. So I invoke my API. It's authenticated correctly, and it sent me the response. So this API now deployed in the AWS side. So now let me go to AWS console and show the analytics event related to this API. So this is my financial API. If I go to dashboard, you can see API invocations here. So if you have like the one central place where you want to apply or like collect all your analytics data, you can pull this data and then create a dashboard across different gateways as well. So I think one main thing I discussed in the previous section is like how you do governance across different APIs, whether they're deployed on AWS or Azure or any other places. So let me show that part a little bit as well. So now I'll go to admin console again, login as admin. So here, when you go to admin portal, you see compliance. Let me click here. So now you can see my financial APIs also appear here. So it's actually deployed on the AWS side, but for the governance, compliance, and the security purposes, we have entry here, and we do run all the checks against this API as well. So let me show how it works. So I'll click on financial API. So here you can see how it's adhering to organization best practices. So likewise, you can see all your governance result from a single place, irrespective of the gateway that we are using underlying. Okay, so for this particular one, you can see there are some policies supported, some violations are there. So then when it comes to warning, there are like 26 different warnings. So let me go and open some of these things. So as you can see here, some of these APIs, this API specifically, we don't have a business owner email. So if it is some mandatory attribute, then we can even make this into error level as well. But for this particular case, it's just warn about having API without proper business email address. And also same with the tags and the tags count, business plan, API business owner details are not there. So all these things you can see one single control plane. Okay, so that's about AWS Gateway part. So now let me go ahead and create API for Kubernetes Gateway. How I do that? I'll go to Publisher again. Okay, so I'll go ahead and create another API. For the simplicity, I'll again go ahead with this approach. For this one, I'm going to use Commute API. For this one, I'm going to pick Kubernetes Gateway. So now you know this is Kubernetes native gateway that deployed in Kubernetes infrastructure. So that is being accessed by the financial services team. Why they need it? Because all their services are based on Kubernetes. So now they need gateway, which is specifically designed for Kubernetes environment. So I think this API already exists. Let me I just read A towards N, so it will pass. I have created this API. So now if I go into deployment section, you see WSO2 APK gateway or WSO2 Kubernetes gateway. So I'll go ahead and deploy to this gateway. Okay, so now that API already deployed into Kubernetes system. So one thing I can do is I can go to my kubectl command and run kubectl get APIs -n APK. So once I run it, as you can see here, this commute API, I think it's this one. So commute API, which is created 16 seconds ago. Let me scroll it a little bit up. So this is what we have created right now. So those who are familiar with the Kubernetes native API management or like the Kubernetes native API deployment, so most of the time you all are preferred with using kubectl command or declarative approach where you use CRs for all your APIs and other assets. So that is exactly what we do here. So if you have any CI/CD pipeline that directly integrate with kubectl command, then again you can use this approach. Basically, you can manage this API in a Kubernetes native way, and we do have CRDs for this one as well. So if you type kubectl describe API and this ID, then you will see all the attributes related to that one as well. So I just want to show you how it is deployed and how we can manage that also from central control plane. So now let me go back to control plane again. For this one, I'm not going to publish into developer portal and go through the same process because it's unnecessary. So for the simplicity, I'll try it from the publisher itself. So I'll generate key. I'll try to get booking. Okay, I think there's a course issue. Let me copy that and run through curl command. So that's easy for me. I'll run -k -v options as well. So you can get a response here. So basically I'm getting response. So that way I invoke our Kubernetes native gateway as well. So now if I go to basically our admin console and see how it is also supporting this compliance thing. So now you can see this commute API is also there. So now this commute API deployed on the Kubernetes gateway, but again, you can manage, govern all these things from this central control plane. Once you click here, you see all the issues associated with that. So that API got again 24 warnings. You can check these things take necessary action to facilitate to follow that best practices. So, and the last one I want to show is, so I think due to time limit, I'll quickly show how we publish one API to our universal gateway as well. So that one I'll real quick start another API. So for that one, I'll go ahead with the Salesforce. So I'll pick universal gateway. And when I go to deployment section, so now you see 4 different gateway environments. So there are like internal, external, EU and API. So actually for this particular use case, like I mentioned earlier, I need to consider only EU and API gateways. So I'm going to tick those 2 gateways. And I'm going to deploy that API. But if there are APIs that you want to deploy to only your EU region, which is like the EU specific use case where you do certain operation related to Europe region, you can pick only that gateway. And also when it comes to API visibility, you can set Europe roles. So only that particular region users will see that API and they can access that API. So that's how it works. For this one, I'm going to pick 2 different gateways for EU and APAC. I'll go ahead, deploy. So now this API deployed, and I'll go ahead with the lifecycle and publish that as well. So showing that in the portal is easier for me. If I go to developer portal, I should be able to see that API now. Yes. So this is the API. When I click on the console, once you go here, you can see 2 different regions like the prod.gateway.apm.com or prod.gateway like the region specific gateway as well. So there are like 2 different URLs here for 2 different regions. As you can see here, there are two URLs that I provided. So then, like I mentioned earlier, in the previous admin part, I show how it works for different role-based access. So if we set this role-based access, then you will see only gateway URL that is applicable to you. So in this case, I haven't done anything like that. That is why I'm seeing both of these API. So then you can invoke this API as well, but I'm not going to do that because you already saw how it works. So if I go to compliance, that API will also come here, and also through that you can see how that API also adhering to best practice. Yeah, so that is what I want to cover in this short demo. So next, Arshad will take over. So in his session, he will mainly cover Ingress and Egress part, and he will show how we can plug different AI systems and apply quality of services for AI APIs. Thank you very much. I think I can take questions towards the end of the session. I'll straight away hand session to Arshad.
Hello everyone. So I hope everyone have learned a lot of things towards the whole Red Room. We went through different topics. I think all of our speakers have covered many diverse areas all across API management. But now what I'm trying to cover now is something you might not have heard about API management, but some of you might have. So let's go through this step by step. So what we have already heard about and what we normally work mostly is with Ingress API management. So what is Ingress API management? So mostly, most of us might use API management for the entry point of our organization. There are different people, different end-use applications trying to now gain access over our APIs. And there we'll have to control access control, authorization, authentication, the usual sort of problems arise. So we are experts at solving this problem, and we have been experts of solving this problem for some time. But now with the world evolving, there's this new requirement to manage and govern outbound API requests that are going outside the organization in addition to requests that are coming in. So with requests that are going outside the organization, there's a new set of problems that you will have to solve. Mostly, people need to actually govern and add compliance to see what data is leaving the organization. For an example, I'll just take a quick example. AI APIs. So one quick point to add there. All this time, Egress API management was a problem in the API management domain. But people didn't realize this much because we didn't have AI and most of these third-party SaaS applications to deal with. But in these days, actually, we'll have to deal with this stuff, and people have to navigate the complexity of actually sending your data outside and actually controlling these interactions. So that's what we identified this requirement, and many customers have come and spoken with us. And therefore, we have gone ahead with this approach where we are assisting you guys to actually govern these codes that are going out and apply governance and management to them. So let me quickly go to a diagram. So you should have already running services in your backend. So here, these are representing these services. So now with this capability, we'll be governing both the ingress and the egress. So I think Sanjeeva previously spoke about a unified control plane, right? So our idea is that this control plane should have both ingress APIs, egress APIs, and ensure that all these APIs are working exactly how you expect it to. And there's no leakage of unnecessary information, unnecessary credentials, and everything is managed properly all across the organization. Yeah, so currently we support the Kubernetes Gateway, Universal Gateway, Immutable Gateway, and other gateways you onboard into API Manager for Ingress. And from our side, we actually support the Universal Gateway and Kubernetes Gateway mainly for Egress, where we have added AI, LLM support through our new features that are coming in. So let me quickly go through that. So as I said earlier, mostly this problem for Egress API management came with the emergence of LLMs. And people needed a way to actually ensure that AI LLM keys used within the organization is properly distributed among your teams. So for an example, let's say there are 2 different backend teams working in your organization. Each of them should have a quota for that team. So for an example, let's say you will have had a discussion with OpenAI, you provisioned a set of tokens to say that, okay, my organization have 30 million tokens to use per month. And now I'm going to distribute them among my internal teams. And now with an AI gateway, we give the capability to manage that. So now you can onboard different vendors. By default, we support Mistral, OpenAI, and OpenAI. So the reason we have gone with these vendors is because initially the requirement came and the request came for us to integrate with OpenAI because that's the mostly used out there. But then there was the requirement to bring in Azure because Azure had a much more better managed endpoint there. And then there was a requirement from developers to actually add this Mistral AI because it was very easy for them to set up and test their stuff. So these are not actually engraved in stone. So you can actually bring in new providers. So we have actually provided the capability to add new providers from the admin portal so that you can onboard new AI providers by giving a spec. So basically, here we are not trying to redefine what the original provider have defined in the specification. For an example, let's say OpenAI have some sort of a way to access the API, that's a contract, right? So we haven't modified that spec. So the unique benefit in this approach is that now if you have already written applications within your organization to utilize these LLM services, you don't need to go ahead and change anything or add a new SDK for us or anything like that. You can just go ahead, change your URL to the gateway URL, and instead of an OpenAI key, you can now provide your developers with keys from API Manager. And now you can integrate that into applications, and now directly you have full control of them. you don't need to go ahead and write new stuff and implement everything again. So that's our motivation behind this decision. So in addition to that, we have this adaptive request handling. So the idea there is that most of the companies might go ahead and say, okay, all across my organization, for every request, I'm going to use GPT-4o. But that might not be the most cost-effective and efficient approach, because as we know, mostly 4 mini kind of models can support most use cases. But for the edge cases where it can't support, then you might have to go to a beta model like 4o. So those stuff you can write within our gateway itself, so that you can manage this stuff adaptively, so that depending on the request that's coming in, you can decide, okay, this should go to 4o, this should go to 4o mini. So we have added that sort of a governance layer as well, so that you have a control there. And of course, finally, last but not the least, you have to have guardrails when your request is going out of the gateway. So you need to say that, okay, certain details of my organization shouldn't be included in this request going out. And you should be able to say that any customer-related data can't go out of the organization. These stuff you can actually implement using guardrails and our mediation capabilities within our gateway. Yeah, so since you're running out of time, so let's quickly go ahead and go to a demo to show you what's the idea behind this and how you can utilize this. So the use case I'm trying to take is Deep Trust AI. It's an organization, a company, who is, so before we move on, any questions, anyone? No, right, everybody's clear? Okay, that's cool. So the use case we are trying to take is that there's an organization now trying to utilize OpenAI. And now they have first set up with GPT-4o, and they have these problems where just being dependent on GPT-4o makes the model get overwhelmed. There can be issues they run into, and there's no backup to fallback. And in case there's error with the backend, the customer's use cases get disrupted. And also, there's this problem with cost efficiency, as I discussed before. For every request, if we start invoking 4o, it can be a huge burden to the company and incur very big costs. And also rate limits, as I mentioned before. There can be certain application teams who utilize a lot of data, and which it can't be fair to other teams because they don't utilize that much. And the key problem here is that we don't have an observability onto what's happening as well. Because you get a key from OpenAI, distributed within your teams, and now each of these teams start invoking this stuff, and within your organization, you don't have any way to actually find out, okay, which team is utilizing more, where should I invest more, what sort of a change I should do with my organization. And lastly, we have this regional backup. So we added this support so that you can configure multiple endpoints and multiple keys, so that we can actually ensure that your organization can keep working without any worries. Yeah. So this is basically a small diagram I just made to actually show you what sort of a complexity we actually minimize. So if you can see here, we have 2 different regions, 2 different deployments running, and it can be a headache for application developers to incorporate all this logic into the applications and handle it themselves, and it's pretty messy. So now we basically bring in the WSO2 Egress AI Gateway, where now you can manage all these requests that are going out and have much more control and visibility onto what's happening. So as I mentioned before, so we have a unified control plane which will always have control and the capability to govern these APIs that are created. Yeah, let's quickly hop on to a demo. Yeah, okay, so let's go to the publisher again. So as Sanjeev mentioned before, so let me first log out. Yeah, so the publisher portal is basically the portal where always somebody comes to actually create the APIs and expose these APIs to the organization and developers. Let me quickly log into it. Yeah, so here I'm going to actually log in with the user Larry, who is a API creator. Yeah, and now, yep. Okay, so let's first of all try something like this. So I'll create a LLM API. So here under APIs, now we have this new AI LLM API. So this was released back in 4.4.0, API Manager 4.4.0. But in the API Manager 4.5.0, we have actually added some additional capabilities for better model routing capabilities. So I'll go through them later on when I'm proceeding with the demo. So here, once you click create AI LLM API, you will see this. So here, we have a list of already onboarded providers. So you can onboard a provider from the admin portal. I'll quickly go through that as well. So as Sanjay mentioned before, let me quickly log out. The admin portal is where admins come into the admins of the organization can come and govern stuff all across the API Manager deployment. So let me quickly log in here. Yep. Okay. Right. So here you will see this new part called AI LLM vendors. So here we have already have the vendors we ship by default. So if you need to add a new LLM vendor, we actually have a document added in our documentation how to onboard Anthropic. So similarly, you can actually bring in any inference model you are running locally as well within the organization. So all we require is a specification as to what sort of API call it accepts and what's the contract. And then we request stuff like in the response sent by the model, what sort of a structure does it have? Where does it say the prompt token count, response model, all this stuff we get because to show analytics and then also to do throttling because we actually depend on the request from the response of the LLM to see how many tokens have been consumed. But in case that you don't get that, you can implement that within the API Manager itself as well, always. Yeah, so hope you guys try this out. So you can onboard your own models and stuff. And please reach out to us if you have any feedback, what sort of things should be added here and what sort of experience you will expect from here. We are always open to feedback. Yeah, let me go ahead and log in back. Yeah. I'm going to turn into Larry again. Yeah. Okay. Okay. Now let's go ahead and again start creating our LLM API. Create a LLM API. So here I'm going to select once you onboard your own LLM, you'll get it in this drop down. So for this moment, I'm going to go with OpenAI. And of course, you have this versioning support in the admin portal side. You can actually have multiple versions of your provider's API. So as I mentioned before, for AI APIs, we currently have Universal and Kubernetes Gateway. So from these two, I'm going to select Universal API for this. And here, let me give a name. Customer support. Right. And let's say version is 1.0.0 and create. So that's all. So developer within the organization who comes to create a LLM API, it's pretty straightforward. Because now we have set everything up. They should just come and give a name version and select the vendor and just go ahead and create it. And yeah, so here, let me quickly go under API configurations, we have endpoints. So this is basically where you configure the key. So once you create the LLM API, so it says here the key is required. So for OpenAI, you all might know, so it utilizes a single endpoint for all deployments. Once you get a key, you can actually use this endpoint to actually do the invocation. So here, let me quickly set this up. So here, first of all, what I'm trying to do is that I'm going to set up a API where the primary endpoint I give is a wrong one. It's a endpoint where the quota is already exceeded. So I'll quickly onboard that and show you. So this is basically to emulate and show you how fallback happens. So let me quickly set this up. I'm going to put my key. Yeah. So this key is basically already throttled out. I'm going to add this here. Yeah. We have configured that, so we don't need the sandbox endpoint here for this use case. Let's delete that. Okay, and now let's go to deployments and select our gateway. We are going to go with the external gateway here because this is our Egress gateway. Yeah, we are going to deploy this. And now let's go to the developer portal. So as Sanjay mentioned, this is where API developers come to actually discover what are the APIs they need and work with them. So let me quickly add this. Yeah. So here, yeah, Larry won't work anymore. Let me quickly log out. So now I'm going to log in with David. David is actually an application developer. So here you might recognize this. This is basically the tenant Sanjeev used for BizLogic. So we have a different tenant to actually show this specific organization. Yeah, let me sign in with David this time. David at Deepcrest AI. Obviously, I'm not going to tell the password. Yep, okay, so, oh, wait a second, we didn't publish the API. Yeah, let's go ahead and publish it. Yep, okay. So the API is published, so that now it's available in the developer portal. Let's quickly hit refresh. Okay, here it is. So this is the custom support LLM API we just created. And let me go to the API console here. Yeah. So actually, let's go and create an application. Let's say customer chatbot. Yeah, and I think 10 per minute is too low. Let's, yeah. Okay. Yeah, we have now created an application and we'll actually generate keys so that we can actually utilize this application to generate tokens. So once you go to APIs, you can go to the custom support API. And yeah, let's go to the API console. You have to subscribe. So yeah, I'm going to subscribe to the API with the custom chatbot application. And now I can get an API key. So basically, we have set this up so that we use API key auth. So in case you need to use something like OAuth from the client side, you can always go to the publisher, and because now this key is basically configured by us. So here under application level security, if you enable basic or auth, you can actually front this using these authentication methods. You don't need to stick to API key only. So these are basically the traditional API management principles that you all might already know of. Yeah, so let's go back to the dev portal. Now we are using API key. And let me call, yeah, I know there's a lot of resources with OpenAI. So let's go with chat completions. That's what most of us use mostly. So just to add something, you can utilize this for any of the resources. So even if you use something like fine tuning or embedding, you can actually front them through the AI gateway as well. Quickly add this here. Okay, so I'm going to ask the LLM, passa capítulo Spain. Yeah, so the LLM responds saying that I have an insufficient quota. So this can be an issue that happens when your API is in production as well. So just imagine this happens when it's in production. So you will need a way to fall back to second option, basically, plan B. So what you're going to do here is that we are going to configure another key. So let's go to endpoints. And now here I have this button called add new endpoint. So here, let me provide an endpoint called failover. Yeah, so the failover endpoint in this case, it's still open chat. Yeah, so here in this case, the new key we provide, the fallback endpoint, let's say the organization have bought a key which have access to 4.0 mini only, because they can't invest for a new key with 4.0. So this is also perfectly fine. You don't need to actually have the same model. You can actually have a much more inferior model as well, just so that you can actually maintain the organization activities. So the model, the key I'm going to provide now, have access to 4 mini only, but that's perfectly fine, because now instead of sending a failure response, I can at least have some business functionality. So I'm going to give this key. Okay, so now we have a default production endpoint and a failover endpoint. So here, under policies, so these are the magic happens. So under common policies, in the new API Manager 4.5.0 release, you will have these new policies. So firstly, I'm going to talk about this model failover. So I'm going to add this into this. So we are going to basically use this for chat completion. So as you recall, we didn't actually use sandbox. We are using production. So here, now I can select first what's the endpoint. So as you might have seen before, we have the default production endpoint and the fallback endpoint. So here what I'm going to select is that my primary use case is to use the production endpoint. That's where it should always try first. And in case this fails, yes, fall back to the second. So let me click this. Now I'm saying that, okay, my production endpoints work with GPT-4.0. And that's what it always need to invoke. And in case this fails, now you can call the fallback endpoint, failover endpoint, and that should utilize GPT-4.0 mini. So this is something you configure in the gateway level. And here I'm going to maybe say request timeout of 30 seconds and a suspend duration of 60 seconds. So here the suspend duration is basically duration. Basically, let's say if the LLM service throttles out, if the throttled out status resets in 60 minutes. Let's say it's a per minute burst control policy that's invoked. So in 60 minutes, it will again try to use the default endpoint. And if it again fails, it again will go to the failover endpoint. Like that, it will happen. So this configuration is basically so that you can configure this. And now I'm going to click save. And so we have this model failover policy. And we can go ahead Yeah, okay. So many resources. Yeah, you can give save and deploy. Yeah, external gateway. Yeah. Okay, so now we have deployed this new revision so that now, yeah, the gateway will magically have failover. So let's try this out. So we don't actually need to refresh this because we are doing a REST call. So must have seen we already have GPT-4. Let me. Try this out. Give me a second. I think I have given the wrong key. Quickly set this up again. Okay. Yeah. Okay. So let me quickly move on with the demo because we are running into time constraints. So yeah. So the idea here is that now you should be able to utilize the 4 mini. It will fall back to the 4 mini model of the other endpoint we configured in the failover endpoint configuration. So let me quickly show one more thing. So here I'm going to actually show this. Yeah. So this is basically a Python backend where I'm already utilizing. So let me quickly show this. App.file. Yeah. So here, this is basically a, I'm not sure whether this is very clear, but let me try my best to show this. Yeah. So this is basically application that have already existed that have called api.openai.com/v1, and now we have actually switched this to our production endpoint of the AI gateway. And basically, all you see is completely similar. So if you can see here, we utilize Chat OpenAI, which is the SDK by LangChain in this case. And it perfectly works with LangChain or OpenAI SDKs or anything. So in this case, now since we have configured the endpoint, all we have to do is to quickly clear this. Yeah, so here, I'm gonna export the OpenAI key. So as you know, OpenAI for LangChain expects this system property to be set. So here, instead of the OpenAI key, I'm gonna set the JWT we generated from the publisher portal, the developer portal, sorry. Yeah, let me quickly go to the developer portal, go to applications, go to app farm. So here, actually the LangChain SDK actually utilizes OAuth2 tokens, where it says authorization bearer and the token. So I'm going to get a normal authorization token instead of a API key. And now I can go ahead and configure it here. Sorry. Right. So this basically directly calls this. So this particular API, I have actually set up load balancing. So you can see initially this is, where is the model here? Yeah, the model name is GPT-4 Mini. Let me call it once again. Yeah, we have again, so I have set this to 50-50 load balancing so that we actually that's the model again. Am I missing that? Wait to see. Yeah, okay. Yeah, so now you can see it goes to 4 like that. Now we can actually switch between different models. So let me quickly show you where the configuration is so that you can try this out as well. So if you go to policies, so this is actually the API I used was AI assistant. So here under policies, we have similarly to the failover policy, we have this load balancing policy where you can give a weighted round robin or round robin load balancing. So here I have given 0.5, 0.5, but then you can actually give any ratio you want to actually utilize. And finally, this is the last thing I saw, analytics for Egress APIs. So this is one of the most impressive stuff we have for Egress management at the moment. Yeah, let me quickly go through this finish. So here you can actually try this out. So here we have actually set up analytics with ELK, and you can actually utilize Choreo analytics as well. We have added this support. So here I want to quickly show the dashboard we have under overview. So we always had this Ingress analytics dashboard previously, which some of you might have knowledge of already. So in addition to that, we have this AI LLM analytics dashboard as well. So if you go here, this have basically a snapshot of all the LLM services you have utilized and all the statistics. So here you can see we have already used 20,500 tokens, and what's the prompt token usage and the completion token usage. You can see that ratio as well. And we have a heat map to see at what times of the day mostly these tokens are getting utilized. And actually we have different dashboards for this to see the traffic patterns. And here basically this is one of the impressive stuff. So here you can see what are the providers mostly used and what are the models of these providers that have been used. So here basically you can see what you need to invest in and all this stuff. So we have errors, latency, and all this stuff. So just try this out and just let us know in the future what sort of a experience you expect from us and what are the advances you will need so that we can actually work with you guys to actually incorporate this stuff and better our product as well and actually flow down the river, as Sanjay mentioned. Yeah, I think that's it. So just before I finish, so in the future there will be some new stuff coming up. So especially in API Manager 4.6.0 and next versions, and you can expect these from Bijira as well. We'll be adding a multi-vendor routing support where you can actually load balance and failover between different vendors now. And we have many plans down the pipeline. And in the future, we'll let you guys know how this stuff evolve. And eventually, we'll have more Egress API types as well, similar to Salesforce, Twilio. And we'll actually have different dashboards in analytics as well to cater towards these scenarios. So please stay tuned and actually stay in touch with us how we can improve ourselves and actually go in this journey together. Yeah, thank you very much, everyone. I think we are open to questions now.
I'm sorry, I don't think we have time for questions, but
you can always reach out.
and meet us. Okay. Actually, Sanjeeva wants to speak a few words.
Yeah. So I would like to thank you all for all your feedback and the support provided throughout this journey. I think a lot of known faces here. So if you look at most of the features that we discuss here, like at least half of the features we directly got from our customers and partners as a request. So we truly value your feedback. So this bringing back micro gateway. So all these came from our customers and partners as a request. And like half of the features we did based on your feedback. So your feedback truly matters. And I would like to thank you all for your continued support and being here today and being with us. Thank you so much.